Hello everyone. So today's video we are going to start with this question. The question says that a function is given f such that r to r and g, a different function is given r to r, are two differentiable functions and gx is defined like this. Here the function is defined in a way that the integral of the fx dx is one entity or one term in this binomial, and x is the second term, and the whole power is given 10, and satisfies this t4 plus fx t5 is equal to 11c4 x to the power 10 for all x belongs to r, where t4 and t5 are as usual the fourth and the fifth terms in the binomial expansion of gx. Then the area bounded by fx and gx is equal to what? So what we have to do, we have to use this relation, and after that we will identify what the function fx is and what the function gx we get. After identification of the function, we have to find the area. We'll use the area bounded by the curves technique, and we will do it. So what we do in this question is, the first thing is we will write, let's say first I'm assuming this integral of fx dx as a new function ux, and I call it for simplicity u, because if I'm writing the general term, of course it will hinder if you write ux and everything. And you understand that if I find the fx, it means the derivative of this integral, so we get u dash or u dash x. So if I have to write the t4, the t4 is going to be, or let me write the direct equation, and in that equation I will substitute those values. So we have given t4 fx t5 11c4. So we know the formula for the binomial expansion, the tr plus 1 general term, that is ncr, a to the power n minus r, b to the power r. So here I can write, for t4 I can write 10c, I need 4, so I substitute 3 there, 3, and the value of a is u, so u to the power n minus, that r, that is 10 minus 3, that is 7, and x to the power 3. The second term fx I can use at u, because u dash rather, because fx is u dash we have assumed, and t5 I can use the same formula, so that will give you 10c4 u to the power 6 and x to the power 4. Now if you notice, we have already done the question, so I can write the answer directly from here. And as soon as I saw the question, and I have seen this before also somewhere, I couldn't recall that time, but now I understand from where this question is taken. There's a very good math teacher whose name is Abhishek Gupta sir. So he has also his YouTube channel. So I think some students recommended the video of that sir, and I have also the book Golden Idea of written by him. So I saw the question given by him in that video, perhaps, if my memory works. So from there, and it's I believe that that question is designed by him only. But anyway, let's try to solve now. So you can see this directly, that here I can substitute x, because you notice that 10c3 and 10c4 will become 11c4. You know the Pascal identity, the ncr plus ncr plus 1 is equal to n plus 1 cr plus 1. So this is 10c3, this is a 10c4, so it will become 11c4. Now if you can guess the value of u means this entire integral u, to make this equation consistent, then we don't have to go into the calculation of differential equation. How can we guess it? You need that this power must be 10, so that it will match here. This power entire should be 10, so they match here. So you notice it will be only possible if I take u as the x because this will become 7 and 3 10. This is 6 and 4 10, and the derivative of u will be 1 because I'm taking u as x. So in this way we can identify that the ux, the function, is going to be x. Therefore our fx should be 1, and from there I can find out the gx function. So gx function is going to be, in this case, is going to be this entire thing is, we notice, remember that this fx is not x, the entire integral is x. So I can write this thing as x plus x to the power 10. So this function will turn out to be 2 to the power 10 x to the power 10. And since fx is 1, now we can find out the area between these two curves. So let's first find out the area by this method. Then I will also give the hint how we can go by differential equation if you cannot guess or see the u function directly. So our area value will become as, first of all, I have to identify this function is nothing but the upside open, and this is y is equal to 1. So this function is fx is equal to 1 here, and we identify that this is y is equal to 1. Now I can find out the area of this trapped region, but that you understand that this region we can find and make it twice. So let's find the area from 0 to this point, and what this point we can find. Let's see. You notice when I substitute x equals to 1 by 2 there, it will be automatically become 1, because 1 by 2 to the power 10 will make it 1. Therefore this value must be x equals to half. So this I'm taking x equals to half so that it will match here. So at half, this is the horizontal line, doesn't matter, it's y is equal to 1, whatever value you substitute. But here if you substitute x equals to half, that will become 1. It means I'm just evaluating the area twice of this, 0 to half, and the upper is 1, lower is this curve. So what I can write, 1 minus 2 to the 10 x to the power 10, and then dx. So of course this will give you twice, and this is x minus 2 to the power 10 x to the power 10, not 10, 11 by 11, and we have to evaluate 0 to half. So this will give it twice of half minus 2 to the power 10 and 1 by 2 to the power 11 into 1 by 11. And after you multiply this 2 inside, that will become 1, and this will become 2 to the power 11, you see, and this is 2 to the power 11, so they will cancel after this multiplication of 2 inside. So we are left with 1 by 11 here, and so we are getting 10 by 11, I think, which is in this option. Yes, option C. Now the question is, how do we deal with this guy if we don't know the, like, we cannot guess, suppose, what is happening. So how do we guess that thing? Not guess, means how can we find the differential, find the function using differential equation? That let's try to understand. So let me copy this thing there. Okay, so this is the function we have, and I'm just going to give you the hint. It's not difficult. You notice that this we can simplify. So 10 factorial, this will going to be 7 factorial 3 factorial, u to the power 7 x to the power 3, this is u dash, this is 10 factorial, 6 factorial 4 factorial, u to the 6 and x to the power 4 is 11 factorial, and this is 7 factorial 4 factorial x to the power 10. Now we can cancel and simplify. I'm just going to give the hint. You notice that this constant is there, so let's just mark this as constant here, this is constant here, and this is constant here. So let's just keep the constant aside. You can simply simplify this by taking the lower number here in the denominator and cancel, and also this is 10 factorial will cancel, here will become 11. So after simplification, I believe here you get 7 and 4 28, here you get 7, and here you get 4, and there you get 11. So let me write it only 1 by 7 perhaps you get, and there we get u dash, and this is 1 by 4 u to the 6 x to the power 4, and this is 11 by 7 into 4, 28. I hope if I'm not calculating wrong, that should we get. Anyway, and after all, also this x will get cancelled, so we get 1 by, okay, let me just multiply by 28, so this will become 4 u to the power 7, and at the same time I am simplifying this x cube, x to the power 4 and x to the power 10. So of course this will give you nothing there because it's the lowest power, and here I get 7 u dash u to the power 6 and 1 x also extra, and here we get 11 because I have multiplied by 28, and here we get 7. Now you can identify easily because this is the number or the term actually whose derivative is already present there. So you can assume this t and its derivative is there, and after that you can apply the linear differential equation in terms of t, and we can identify from there. So this is not difficult, it is doable. Let's move to the next question now. This question is a cubic equation with real coefficient px is equal to 0 has one real root alpha and two imaginary roots beta plus minus iota gamma, represented by a, b, c on the Argand plane respectively. Then okay, so one thing is for clear, this thing is that beta, so let's try to draw the diagram first, how this complex numbers position and the real numbers with the roots position look like. So let's say beta plus iota gamma is one of the root there, that is r1, let's say I'm calling it the root r1, beta plus iota gamma is here, and just below it at the image of this r1 there is a r1 bar I can say, or let's say r2 I'm calling it, it's a beta minus iota gamma. Now this alpha, the root alpha, please remember beta gamma are not the roots, they are real numbers actually, and they are combining to give the roots r1 and r2. So basically the cube has 3 roots, and those roots are alpha, r1 and r2, where r1 is beta plus iota gamma and r2 is the conjugate of it. Alpha is because this is a cubic equation, and 2 roots already we have found as imaginary conjugate or complex conjugate, so remaining root, leftover 1 root must be a real root. Therefore I'm just assuming this is a real axis or the x-axis, means alpha is somewhere here on this real axis. So let's say this is alpha, here is located. Okay, so these are the 3 roots I have, and now let's go to the question. So the first part what they're asking is roots of p dash x is equal to 0 are imaginary if a lies, what is a by the way, a, b, c are the Argand plane. So what is a here, a, b, c on the Argand plane, what is a, oh, the roots are the, so a is the first root, that is alpha respectively they are saying. Let's say this is beta plus iota gamma is b, and this is c. So this a, b, c are the location of these roots. Now reread the question. Roots of p dash x equal to 0 are imaginary if a lies inside one of the 2 equilateral triangles with base bc. Oh, so what they're asking that if I draw this equilateral triangle like this alpha is inside it. It can be drawn here also, this side, so this alpha will go here. So how can we draw this equilateral triangle? Means one side is already known. Let's try. So for this equilateral triangle, for the first part of the question, I can say the BC length is already I have 2 iota gamma, so length I can say 2 gamma, and gamma I don't know whether positive or negative, so I call it a 2 mod gamma because okay. Now this, if I take any point M here and if A is inside that, so okay, so let's do in this way. Better approach, what we can do, okay, let's try this way. Identify, and this is also, let's say that if it's an equilateral triangle we are finding, so BM length and CM length will be the same as this BC, and we can also find not, yeah, BM, okay, this is same na, yeah. All right, so okay, so let's say I have, they're saying that and A lies one of the two equilateral. So what we can do, let's say I have a px which has 3 roots like this, x minus alpha, and the other 2 roots I have x minus r1 into x minus r2. I think I cracked it. X minus alpha, and this I can write x square minus r1 plus r2 x plus r1 into r2. Okay, yes, I got it. Now you notice that this I can write x squared and minus r1 plus r2 is nothing but 2 beta, so it'll become 2 beta x, and r1 into r2 is beta squared plus gamma squared. Now they're asking the roots of p dash x. So roots of p dash x means let's find the p dash x. So I'm just finding the product, using the product rule to find the derivative. So this will become x minus alpha, and this is 2x minus 2 beta. Wow, this is constant. Now x square minus 2 beta x plus beta square plus gamma square, and that is going to be 1. Yes, a very good question. Now see what is happening. This maybe you can be confused that this is always providing the imaginary roots and this must be imaginary. It's not like that. There are 2 different quadratics you are adding. Let me convince what I'm saying. This 2 you can take it out, and this is nothing but x minus alpha, x minus beta. Remember, beta is the real part of one of the root. Now this is x square minus 2 beta x plus beta squared plus gamma square. I can guess something wonderful is going to happen. Let's see here. This is going to be x square minus alpha plus beta x and plus alpha beta, and here x square minus 2 beta x plus beta square plus gamma square. Now notice one thing. These are the two, this equation is, of course, they are going to give us imaginary roots. It doesn't mean that this has to be imaginary. Collectively, what is going to happen, that the p dash x must have a imaginary roots. So we cannot say by just sum of two quadratics, we cannot say. So to combine it and then create a new quadratic and see the discriminant of that quadratic is lesser than 0 or not, we impose that condition, and from there we get the condition on alpha, beta, gamma that we require actually. So let's combine this, and what will happen? 2x square plus x square is 3x square, and notice here minus 2 alpha plus beta and minus 2 beta. So this will become minus of, I can write minus 2 times alpha plus 2 beta x, because I'm taking 2 only common from there. Notice here also I took 2 common, and here also if you multiplied I took 2 common. So alpha plus beta and beta will get added. And now what I did, yes, so after that we multiply these two, so we get 2 alpha beta here, and from there what I get, 2 alpha beta and plus beta square plus gamma square. All right. Now this is a quadratic equation we got, and we have to find out the discriminant of this, and that discriminant should be lesser than 0 for the imaginary roots what the question is demanding. So discriminant is less than 0, so let's find the discriminant. This is going to be 4 alpha plus 2 beta the whole square minus 4 into 3 into 2 alpha beta plus beta square plus gamma square, that must be less than 0. Now this 4 will get out, and then now expand this thing. So alpha square plus 4 beta square plus 4 alpha beta 2ab, and this 4 is already gone. So here I can get now 3 to the 6 alpha beta minus 3 beta square minus 3 gamma square lesser than 0. All right, now I can see something fishy is happening here. 4 alpha beta minus 6, so let's collect alpha square, and this is 4 alpha beta minus 2 alpha beta. 6 alpha beta is minus 2 alpha beta, and 4 beta square minus 3 beta square, this 2 is beta square. Wonderful. It means this I can write alpha minus beta the whole square is lesser than 3 gamma square. And now we take this root. So alpha minus beta mod must be lesser than 3 mod gamma. Yes, so now I can write that alpha minus beta lies between 3 mod gamma, not 3, it's a root 3 by the way, root 3 mod gamma to root 3 mod gamma minus root 3 mod gamma to this. So I can write alpha lies between beta minus root 3 mod gamma and beta plus root 3. I'm trying to visualize at the same time. Yes, so this is the condition we got for the imaginary roots. Now let's try to visualize this whole situation in the picture we have drawn. What the situation we have? Alpha should lie from beta minus root 3 gamma. So notice that if I want, let me draw this first. So let us join these two sides. Okay, this length, can we tell what is this length from here to here, this half of it, because this is total is 2 gamma, so this will become mod gamma. I'm taking mod because I don't know what the value, the sign of the gamma, and this is already I have 2 mod gamma. It means suppose I taking this as n. So what we can tell about the mn? So mn is nothing but this is the right angle triangle, or this is the right angle triangle in which this length is 2 mod gamma and this is mod gamma. So 4 mod gamma means 4 gamma square minus gamma square, 3 gamma square, that is root 3 mod gamma. So this length mn is root 3 mod gamma. Now this position, this is on real axis, is beta comma 0. It means suppose you want to locate alpha, you notice that what is happening is very interesting. Wow, is actually if you want to locate this alpha from this beta, if you are going this side, you are taking beta minus root 3 mod gamma, and if you are drawing a triangle this side and the alpha is there, then you can say beta plus root 3 gamma. It means that the alpha lies between beta minus root 3 gamma and beta plus root 3 gamma. Therefore, for that position of alpha in which you are drawing an equilateral triangle, and if the alpha is lying inside that equilateral triangle where base is BC, the roots are imaginary. So that's a very good question. So therefore, this is correct. The second part is roots of pdx are real if A lies inside one of the two equilateral triangles. Real they're asking, so of course already imaginary we have proved. Roots of pdx are imaginary if ABC are vertices of ABC are vertices of isosceles triangle. It is not actually necessary. What they're saying, roots of pdx are imaginary, but if ABC, if it is exactly at A, then how we can say it? Means that if this is equilateral, you are saying, and roots are imaginary, but alpha should be inside it. So how can be imaginary? Because imaginary we have already proved it. So this is also roots of pdx are real and equal if alpha minus beta by gamma is this. So of course we have actually taken this discriminant, and from there if you look at this condition, this is lesser than 0. If I make it equal to 0, I can get alpha minus beta whole square is 3 gamma square. Therefore alpha minus beta mod is equal to 3 mod gamma, and from there we can get that alpha minus beta by gamma is equal to plus or minus by the way root 3 there, root 3. So this part is also correct. So I guess the A and D are correct. Now let's move to the next question. Okay, so this question, for that I have to pause the video and I just drew it just to explain. The question is A is x, means this is not cap here, the cap should be there, it's a typo. So this A is a set of this x, y, z point in R cube x square plus y square z square. So please understand, this x square plus y square plus z square is equal to 1 represents a sphere in 3D geometry or in the 3D space where the center is 0, 0, 0 and the radius will be origin. So let's call that this is the center 0, 0, 0, and here I am taking one radius for the purpose. So let me draw it. This is a radius here. Oops. Okay, so the radius is 1 there, and now this is another set of xyz which is satisfied by this. So if you just open the mod, there are two different planes will come out. Why? Because root 3x plus 2y plus 3z minus 16 is equal to 14. That will give you root 3x plus 2y plus 3z is equal to 30. And other, this is let's say plane 1, and the other will be, if you take here minus sign, that will become root 3x plus 2y, so minus 14, and you are taking that thing, so plus 2 will come, plus 3z is equal to 2. This is plane 2. Now we have to identify that whether this A and B are intersecting, it means the plane and the sphere are intersecting each other or not. So for that is a very simple litmus test, that we can find the length of perpendicular drawn from the center of the sphere to that plane. And if that length, let's say this length is what I call the distance d, let's say d. If d is greater than radius is 1, then this plane no intersection, no interaction. But if d is lesser than 1 or equal to 1, it means there is some interaction. If the 1 exactly, then it will be touching and so on. The simple, like the simple analogous concept what we do for the circle and the line for tangency. So here there is a yes intersection will happen. So let's identify first. So for the P1, if I find the distance, what we get, if I putting 0, 0, 0, so this will become 30 divided by root over 3 plus 4, 7 and 9, 16. So root 16, that is going to be 30 by 4, that is 15 by 2. 15 by 2 is a very high number compared to 1, so that is not the intersection. So first plane is failed. Second plane for P2, the D1, D I am finding So that is going to be 2 by root 16, that is 2 by 4, so going to be 1/2. So 1 by 2, so D is equal to 1 by 2, and this is the plane I required. Now what they're asking, that if the intersection happened, in that intersection we are taking 3 position vectors or 3 points on that intersection set, so that the distance between any of the two is like equal to other two. It means it is actually creating an equilateral triangle. So how does it creating an equilateral triangle? Suppose I have these 3 points. Let me draw a new picture so that I can convince. So this is, let's say I have A over here, B over here, and C over here. So A, B, C, and they are saying that the position vector of these points are given as ABC. So when this is the position vector and we have this, the center is somewhere here, means this center of this circle is somewhere here. So let me, okay, so I'm just mixing up two things, but let's try. So this is like that, we have this triangle, and if I join this, how can I draw? Let me just cut this first. It is here, and the idea is that suppose I have this center over here of the sphere, and I connect these with the center, 3 vertices, you notice we get a pyramid. Okay, so this is actually the prism. Is an equilateral triangle, is a prism. The volume V denotes the parallel pipe determined by the vectors. Okay, so if, all right, so the idea is that if this is B vector, this is C vector, and this is A vector, so we are looking from that point of view that these are the adjacent 3 vectors, and from there we have to decide the volume we can find. Now we can drop the perpendicular here, notice, and that perpendicular already we have found, and we can find the area of the base triangle, which is equilateral, and if I find the area we can multiply by D, so that will become area into height, volume. So how do we decide the area of the triangle? So for area of triangle, you know that the area of an equilateral triangle is what? Root 3 by 4 the side square. We don't know the side length, we have to find it. So please understand, this length we already know, the radius of this circle. Sorry, we don't know, we have to find it out. How do we decide the radius of this circle? Let's decide. If this is the cross section circle, and this length we already found, that is half from the origin, and the radius is already we have, which is 1. So we can join this and we will get this length, which is the radius of the circle. So R we can get as 1 minus 1 by 4, that is root 3 by 2. Now once we get this root 3 by 2 here, this length is root 3 by 2. Now the situation is this one. There is a triangle which is equilateral, and we have this length given, and we can find, because now notice that this is the chord of the circle, so it will bisect, this length will be bisecting there, and we have done this kind of things in 2D geometry many times. So let's say this length is A by 2. What is A by 2? Means half of this side of the equilateral triangle, and you notice that this must be 30 degree, and here this is already I have given, means I am given with the root 3 by 2. So we can apply here cos theta. So cos 30 degree if it is equal to a by 2 by this thing, so we'll give it 2 by root 3. So here cos 30 is root 3 by 2 is equal to a by 2 by root 3, 2 cancel, and a will become 3 by 2. So the side length I got is 3 by 2 and this distance is half. So the volume of tetrahedron, so this volume of, the area of circle, triangle. So area of triangle will be root 3 by 4 side square. So 3 by 2 square. So root 3 by 16 I got here, and that is going to be 9 root 3 by 16. And if I multiply this thing by 1 by 2, I should get, the volume of parallelepiped. Yes, because we are taking this base and we are multiplying by half. So what I'm getting is multiplying by half, then volume of parallelepiped we get, not the volume of this trapezium we get. So volume of parallelepiped is going to be what was that, 1 by 2 into 9 root 3 by 16. I don't know what the answer is given, but let's try. 32, and after that I have to substitute in 16 root 3 v. So this is the v I have. So 16 root 3 into 9 root 3 by 32. I'm getting 16 to rational value, that means 16 by 2, and that is 27 by 2 is the volume I'm achieving. So this is the question in which we will apply this technique. Let's move to the next question, and this question comes from polynomial again. The question is, I have a polynomial f of fx plus 1 minus pf. This kind of questions we have done many times in different classes. Okay, so this f of fx 1 minus pfx root 3. See that the right hand side is constant. If the right hand side is constant, this f of fx cannot be a polynomial of degree 2 or 3. Why? Because there is no chance to get 3 if you take the composition of any polynomial whose degree is more than 1. Because it should suppose you are making the composition of x, the degree 2 with degree 2, it will become degree 4, and so on. So of course we cannot get the right hand side constant, so our guess must be that the coefficient of fx, leading coefficient is 2, it must be a linear coefficient, linear function. So fx linear polynomial, so I am taking that linear polynomial anyway, linear function. So 2x plus any constant, let's say k here I am taking, this I am assuming. Now they're asking this thing, the derivative of f of fx at, so we can differentiate directly, but let's find it. So we are finding there by comparing. So let's say I'm finding f of fx. So f of fx means 2 of fx plus k, and we again impose f of fx, that will come as, because we are substituting this f of fx inside the fx, so I will get here twice of notice that what I'm about to say, this is f of fx, you are going to substitute this thing back again inside this function. So what we're getting is twice of fx plus k plus k. I hope it will work. And this is 4 fx plus 3k. You see, in a linear there is a facility that when you are making the composition, you are getting again the linear back. We are not getting a square and all, so it's again function fx, we can substitute it with this original function. So 4 times twice of x plus k and plus 3k. So we are getting 8x plus 7k. Now let's substitute this thing there. So we are getting here 8x plus 7k, 1 minus p, and again 2x plus k is equal to 3. Now how do we find the value of p? That's the important thing. So here we can just collect the coefficients of x and constant terms and we compare with both sides. So here what I'm getting is 8 and plus 1 minus p the whole with x, and the constant I'm getting 7k plus 1 minus pk is equal to 3. So we can compare this p. Wow, what p I'm getting? 9. This is 2, by the way, here 2, and p should be 9. No, oh no, well, let's calculate it. So that must be 0 here, that must be 0. So if I substitute p is equal to 5, that will become 0. 8 plus 2, 1 minus p is equal to 0, because the leading coefficient this side is 0, they're constant only, so coefficient of x should be 0. So from there I'm getting p is equal to 5. If I get p is equal to 5, this I can compare with 3. So 7k plus 1 minus 5 times k is equal to 3. So this will become 7k minus 1 minus 5 minus 4. So 3k is equal to 3. So k is equal to 1. It means I identified both of these things. The 2x plus 1 is the function and the p value is 5. So I have function is equal to 2x plus 1. If I have to find the inverse, because they are asking the inverse also in the question here, so f inverse directly we can write, that is what? X minus 1 by 2. And they're asking the derivative of f of fx. So f of fx is, we can find the derivative directly. We can write here f dash of fx into f dash x. Now f dash of fx, and we have to find at the value p. So let's substitute p there. So at p it will give you f dash of fp and f dash of p. But what is p? P is 5. So fp is 5. This 5 means I have, by the way, if you substitute, now see this thing, the beauty, if you substitute anything there and again you differentiate to evaluate it, you get only the constant term, because, okay, let me just convince. What you want to say that f of p is what? F dash of p, fp is 5. So f dash of 5 means I am just substituting there 5, not 5, 5 to the 10, 11. No, it's 5 now, yes, f dash of 5, and this is f dash of 5. What is f dash? Again, there is 2 only, and this is also 2, so that value is 4. Now let's look at this here, the second part of this. Second part is minus p to p twice of, okay. So minus p to p means minus 5 to 5, and this is twice of f inverse x plus 1, I think, yes. So twice, yes. So twice of f inverse x means just x, so it will become x minus 5 to 5, and that will become x only, because this one also get cancelled. So this is going to be 0 because it's an odd function. So answer is 4 only. 4 plus 0 is 4. So option C is correct one. Alright, so that's all for today's video. See you in the next video with some other good questions, and next time perhaps I will take some GTA from different institution, not from Sri Chaitanya. So Till then, stay math active.